Okay, we're going to start Unit 3, and Unit 3 begins and majorly is all about lines and the different types of relationships between lines. We jump to a little bit of proofs in the middle. Your first touch of proofs in the unit will be about lines again. And then at the end, it kind of closes with slope review, stuff that you did in Algebra 1, so hopefully the end of this unit will just be a refresher. But we're going to start with Lesson 1, talking about parallel lines. Okay, so we've talked about parallel lines before. Those are two lines that never touch. So think about the double white lines on the road, or the person at the airport, flagging the planes in. They have those like light up cones. They never touch. We use arrows, these arrows right here, to show that those lines are parallel, because in geometry we always need a symbol. We always need something to prove it. An angle might look like it's 90 degrees, but without that little box in the corner, how do we know? This is how we know that those are parallel. And then symbolically, we write that with the little, it looks like an 11. Okay, but again, think about those lines that go up and down that never touch. This is saying that line AB is parallel to CD. Similarly, planes that never touch are also parallel. So think about two pieces of paper that you've laid flat, or a box, right, an Amazon box. If you get something delivered, the top of the box and the bottom of the box are the same parallel planes, just like the left and the right, the front and the back. We use the same exact notation to denote parallel of those two lines that go up and down. And then here's a new type of line, a skew line. A skew line are non-coplanar lines that do not touch. So here I have a couple examples. Looking at the green, PQ and UV. PQ is going left and right and is on the bottom. And then this one is going kind of forward and backward and it's on the top. Those are skew. They'll never touch no matter how long those lines extend in a plane. Same deal with the red and same deal with the purple. Hopefully those are good examples that show you that those lines, even if you extend them forever, they're never gonna touch. What an important thing to note here is if, say we had this one and that one. Okay. Now they're both on different planes, one's on the bottom, one's on the top, and if I extend them forever, they're never gonna touch. But these are not skew, because these are actually parallel. They're going in the same direction forever, and they'll never touch. The skew lines go in different directions, up, down, left, right, okay, and then left, right, up, down. When you're gonna name skew stuff, try to choose that. Try to get one maybe that's going side to side, another one up and down. We wanna have that. So here we have an example. All segments parallel to AE. All right, well I've gone and highlighted what AE is. Let's go and find the other ones. Looks like we're looking for all the ones that go straight up and down. So that one, this one, and that one. Those are all my parallel lines to that. I don't think I have any more. So HD and FB and GC. Okay. Two examples of parallel planes. So again, think of this like your Amazon box. You want two sides that are never ever gonna touch. I can do the left and the right. Okay, I can name that. Those sides of the box will never touch. And remember, if we name planes, we need 3 letters. So I'm gonna call the plane on the left, any 3 that I choose, A, D, H. And the one on the right, I'll do B, C, G. Two more, let's say I want to do the top and the bottom of this box. There's the top, there's the bottom, and if I'm going to name those, I'm going to use 3 letters to name it. ABC, easy enough for the bottom, and then the top, EHG. Name all segments skew. Okay, so let's see what we have. Skew to GH. So again, I want different planes and never ever gonna touch. So let's see. This one's going left and right. How about all the ones that go up and down? That one's going up and down and won't touch. This one's going up and down and won't touch. This one right here, GC, that's going up and down. But look how it directly touches that red, so that's not good. I don't want to do that one. Okay, so I think I got all my up and downs that don't touch, but there's more. This one's going left and right. How about the ones that are going forward? So that end of the box is going forward, same with this. And I think that's it for me. Skew lines that don't touch. Any other thing up here would be touching this original red. Remember, this is where I started. That would be touching, this would be touching. This line is parallel, it's going in the same direction, so that's not skew, it's parallel. And then same with this one back here, that's parallel, and this one's parallel. So I got them all. So I'm gonna name them EA, let's see, FB, BC, and AD. Alright, now we have a little bit more of a complicated shape, but the questions are still simple if we take them one at a time. All segments parallel to JK. Well, JK is right here. So I want all segments that are parallel. I want ones that are going in the same direction and will lay flat. Let's see. I only see one. OP. I don't see any other lines that are parallel. That's the only one on the bottom floor of this shape, but all these other ones up here are like angled. Okay, they're not perfectly flat like this one. So that's it, actually. All segments parallel to NS. Okay. So I think maybe this is a birdhouse if you want to think of it. It looks like a little bit like a birdhouse. We want all parts of the birdhouse that are going back in line with that. So parallel to this, I see that one, this one, that one, and that one. Those four are my parallel, and there are no others. So MR, LQ, KP, and the last one was JO. Okay, name a plane parallel to JKL. So let's see, what plane is that talking about? J to K to L. It looks like it's the front of this birdhouse. So if I just follow tracing that shape, I'm talking about this plane here. So I'm looking for the plane that goes in the same direction. Well, if that's the front of it, it's gonna be the back of it. So this plane back here. And to name a plane, we use 3 letters, so any 3 will do. SRQ. Then our last question here, name 4 segments skew. Okay, so I'm trying to find some skew lines. RQ. All right, so it says 4, it doesn't say all. That means there's gonna be lots of options we can do here. Remember, skew is different plane, never touching. So I've got this one that's kind of going. I'm gonna highlight this dark so I know where I started. This one is kind of going up and down. This one, they're not touching. If I extend those lines forever, they're never gonna touch. So that makes sense. I started with this one. What about down here? Another one that's going straight at me. How about another one that's going straight at me? Well, that's 3 real quick that I found to be skew. If one is skew, I can kind of poke at these other ones easily enough. And then I just want a line I ran out of the ones going straight at me because this one would touch and this one would touch my starting point. So I need to go somewhere else. I can't do this, because it's parallel, but I can do this. It's laying flat, it's going left and right, this one's kind of up and down. All of those will work. And there's more, but those are just the examples I'm gonna give here. SN, JO, JK, and then KP. All right. A transversal is a line that connects 2 or more lines. So if we see in this image here, L and M, they have that line T that's crossing it at 2 places. You have angle relationships when you have a transversal, and these angle relationships are so important. They stay with us for the entirety of the course. So really, try to get these down. But it's the first time we're seeing them. Corresponding angles. Corresponding means really the same. angles that are in the same position. So what do I mean by that? Look at this cluster up here, 1, 2, 3, 4. You see how there are 4 angles made by the intersection of T and L, 4 pieces here? I have the same 4 pieces down here, but corresponding is in the same position. So number 1 and number 5 are in the top left. Those are corresponding angles. Similarly, I'm not going to name all of them, but 3 and 7, they're in the bottom right. Okay, that's corresponding, same position. So I have 1 and 5, and 3 and 7. Okay, there are more, but I'm going to do all of them. Okay, we're doing green. That's not a nice green. Alternate interior angles. Okay, so this is a tricky part. If I think about this, it's a terrible analogy, but if I think about it like a hamburger, okay? I have an inside where these numbers are, and I have an outside. So maybe you think about it like, here's the top of the bun, here's the bottom of the bun, and then all the good stuff, the meat, the cheese, the lettuce, the tomato, pickle, especially pickle, it's all on the inside of this sandwich, okay? Interior, inside. Exterior, outside. But right now we're talking about the interior. So I'm talking about the numbers that are inside this shape. And then alternate, the other piece of this, means opposite side. So something like 4 and 6. That would be alternate. The only other example, well, 3 and 5. Okay, 4 and 6, 3 and 5. Those are alternate interior. 4 and 6, 3 and 5. All right, gold next. Okay, so now alternate exterior angles, same deal. Alternate means opposite side of that transversal. Exterior means on the outside of it. So something like 1 and 7. Okay, they're both on the outside and they're on the opposite. This is on the left side of this line. This one's on the right. And then 2 and 8. So I had 1 and 7, 2 and 8. Consecutive same side interior. So sometimes you'll hear about this as same side interior or consecutive interior. It means the same thing. Pick whichever one you like. I'm going to probably talk about consecutive angles for the course, but you might hear me call them same side. It's the same thing, interior, exterior. We're talking about the same region, so inside the hamburger, outside. But now instead of alternate, opposite sides, it's just going to be the same. So same side, inside, 4, 5. And the other pair then would be 3 and 6. And the last one we have here, consecutive exterior. Whoops. So, same side, outside, same side, outside. So, 1 and 8, and then 2 and 7. Okay, so this is very important. Focus on understanding this, hopefully, and it will help you for the rest of the course. Example 3, identify the relationship. If none exists, write none. It's totally possible that we don't have a description that matches. Let's see here. All right, 1 and 8. 1 and 8. All right. Well, it looks like my hamburger here, it was flat before, now it's just on its side. So my bun, if you want to view this like the hamburger, okay, it shifted on its side. The inside, where the good stuff of the hamburger is in the middle here. This is the inside. So 1 and 8. They're both on the outside. So I have exterior. And it looks like they're on opposite sides. This one's on the top, this one's on the bottom. So we're gonna do alternate exterior. 2, and 3. All right, well, those are both on the inside, and it looks like they're on the same side. So same side, we call consecutive. And inside is interior. 5 and 7. Okay, so here's the thing. I got 1 on the inside. 7 is in the inside, but 5's on the outside. The only shot you have when you have 1 inside and 1 outside is that they are corresponding. So same position. So we're gonna check. In this cluster of 4, it looks like 5 is in the bottom left. Over here, 7, bottom left. So yeah, they are corresponding. And I hope you can keep going and find the rest. There might be none. Let's see right there. That one's not, that one's not. 5 and 8. Now, okay. Down here, something that's a little bit more complicated. Now I have many transversals and lots of different lines. But let's pick it apart, see what we can figure out. 5 and 13. All right, so here, I need to figure out what kind of relationship they have. But there's too much going on in this picture. So it might be helpful to limit it, narrow it down. Right now, 5 and 13, the line they both share, the transversal, is B. So I care about this line. If I take something, maybe a piece of paper, and I cover up the other part of the problem, that might help me focus because this left half of it has nothing to do with this anymore. Now I can check. Okay, 1 is on the outside, 1 is on the inside. My only hope is that they're corresponding. Top left, top left. Okay, so 5 and 13 are corresponding. Okay, 7 and 14. It looks like we're staying over here. It looks like they're both on the inside of that hamburger. 1 is on the left, 1 is on the right. Alternate inside, so interior. Alternate interior. Three, 6. Okay. This time my 2 points are sharing the transversal of C. They're both on this line. They're both touching. The green's touching this line. The green is also, or the 3 is also touching. So I'm going to cover up the bottom. And now I can only focus on the top. Well, this is where my hamburger is changed. It's floated, or it's on the side now. So the outside is over here and here. My inside is here. So it looks like they're both on the outside, so I have exterior. And they're both on opposite sides. 1 is on the bottom, the other is on the top. So alternate exterior. Okay, so the transversal is D, we're on the bottom. It looks like they're both on the outside of this hamburger, not on the inside, on the outside. And they're on the same side, on the top of it. So same side, outside, we call that consecutive exterior. Four, 7, 4, 7. So now we're talking up here. I'm inside of my hamburger and on the same side, the bottom. So I have another consecutive interior. Two and 10. We're talking about this side. Looks like 1 is on the outside, 1 is on the inside. So my only shot is corresponding. Top right, top right. Okay, we do have corresponding. And let's finish this up. 8 and 14, 8 and 14. All right. Over here, inside, same side, consecutive interior. So 11 is touching this line here, and it's touching this line here. There's no line that connects 11 and 6. I can't like cross off half this problem. I can't make this work. There's not one common transversal that both numbers share. 11's over here, that one's over there. They're on complete opposite sides. They don't have a touch point. So this is actually one of those ones that's none. Sometimes you will have no relationship. You have to have them both on the same line for any of this to work. So if that's not happening, you don't have a relationship. Okay. I wanted to get that example out of the way so we can stop there. Okay. Angles formed by a transversal. So now we're going to start filling in our own examples. But let's figure out the transversal first. 1 and 12. The line that they both share, the line that they are both on, is L. It is this line here. Line L. 3, 6. The line these green ones share is this one, so it's going to be line J. What do we got? 7 and 15. Transversal is this one. They both are on that line, and it is M. And last, black, 12 and 14. I already used 12. It's boring. Okay. Looks like this line here is the one that connects this one to that one. So K. All right, so let's use some examples. Corresponding angles, any that we choose. So, I don't know, start with number 1. I'm looking for something that's in the same position as that one and on the same line. So, same line would be if I follow this down here to this cluster of 4, I could use this. 1 is in the top left, so the top left one of these ones is 9. But I could keep going. Instead of going down to this one here, I can go over to this one. Again, this is in the top left, so if I go over here, the top left would be 5. 1 and 5. I'll tell you, I can't do 1 and 13, even though they're both in the top left of their like cluster of numbers, because there's no one line that gets me from 1 to 13. I have to like think about it like a subway. I have to go down here and then take that one over, right? There's no direct line to that, so that does not work. Alternate interior. Okay, so let's just pick any point. Now I want opposite sides and inside. So if I try to work with this one up here and like cross this off and not focus on it, this one's now on the outside of the hamburger where this stuff is in the middle and my bun would be up like that. So that one won't work for me. But if I cross the top off and only focus on the bottom, now my inside becomes here. So that is the tricky part. Your inside and your outside will change depending on how you're looking at the problem. So my inside is here. My outside of the hamburger is out here. Alternate means opposite side. So 11 and 14. Another example would be, let's go 8. Okay. Well, now if I cross off the bottom, 8 and this cluster over here, 8's on the outside of the hamburger. So I need to maybe work like this, where 8 is now in the middle on the inside. And opposite of that would be 13. alternate exterior, again, pick anyone. 2. If I'm working with this cluster, it's on the inside, so that won't work, which means I need to work with it over here. And I'm looking for alternate outside, so 2 is on the bottom, 7 is on the top. And I guess let's do one more. 14. Oh, well look, I already accidentally did it. 7 and 14 are already alternate exterior. They're both on the outside of this hamburger. One's on the right, one's on the left. Whoops. Now we're talking about consecutive, the same side on the inside. All right, well I want the inside, so I'm gonna go with 11. Let's see. If I work with this left side here, looks like the inside is right there, not the outside. So same side as this 11 is actually gonna be 4. And since I picked 11, I can stick with it, and I can work over here now, because 11 and this stuff are on the inside already. This is the outside. This is the inside. So the same side inside here, 11 and 13. And our last one, I guess purple. I want consecutive outside, so let's pick anything on the outside. Go 7. Same side outside, so let's see. Outside, no, sorry, this would be the inside. Outside here would be up and bottom. So I'm looking at these two, but I want the same side, so 16. And actually I can work with this one again. 7 is, let's see, on the outside of this, because this again would be the inside. Outside, same side, 1.